Okay. So yeah, so welcome everybody to today's seminars. I'm very happy to introduce Dita Eckardt, who will be speaking to us today. So Dita got her PhD at the LSE in 2020, and she's now an assistant professor at the University of Warwick. And she's working in labor economics, public economics, and applied econometrics. And her main focus is on training and specificity of human capital. So today she's going to talk about the effects of labor market entry conditions on job match quality. And it is evidence from apprenticeships in Germany. So I'm very much looking forward to your talk. So in terms of the format of the seminar, we have 60 minutes. So we would like to split it into 40 minutes of talk and 20 minutes of discussion. But so we are also always open, or Dita is open, to take a short question in between. So clarifying questions in particular, but also if you have any short questions so that we can get a bit of a discussion also during the talk. Okay, yeah, and then I wanted to say that we also should today celebrate the Nobel Prize Claudia Goldin won for her analysis of female labor markets. So I'm super thrilled about this, and this is a very good opportunity for this seminar, I think. Okay, so thanks, Dita. Go ahead.
Thank you so much. Yeah, thanks everyone for being here today. I'm really looking forward to this presentation. So to motivate this paper, let me start with this motivation that the first years in the labor market are really an extremely important time for workers' careers. So this is a time where one thing that happens is that workers very actively search for good job matches that they then tend to keep in the long run. And it's also a time where workers have been found to be particularly vulnerable to economic shocks. And so we know that, for instance, long-term earnings, they are affected by adverse entry conditions or adverse events like layoffs in the first years. And so I think there's at least two good reasons to think that these entry conditions would also affect job match quality of workers. And this is sort of beyond the fact that just the search happens to be in the early years as well. And these two reasons are that, well, firstly, match quality tends to be worse in recessions in the aggregate. And this is due to congestion in the labor market. Now, we might think that this is particularly bad for labor market entrants because they face more information problems. They simply don't have sort of long CVs to show to prospective employers yet. The other reason is that recessions, of course, they tend to be not just absolute shocks, but also relative shocks. And so if workers reallocate to areas of the economy that are less affected by these shocks, that could also matter for job match quality, affect their job matches. And so, of course, to look at the effects of entry conditions on these job matches, what we need is good measures of matches, good measures of quality. But it turns out that job match quality is actually something that's pretty hard to quantify. We intuitively think that it's related to occupational matching because graduates, they're typically trained in specific fields, and we know from the literature that skills don't necessarily fully transfer across different occupations. But again, occupational matches are typically pretty hard to define. And so what I do in this project is I look at the job match quality of apprenticeship graduates. And this is an interesting group because it actually turns out it's the largest group of labor market entrants in many countries, including Germany, which is the focus of my study. It's not just the largest group, it's actually the majority of labor market entrants as well. So it's a very sizable group of workers. What's important about this group relating to the data or measurement issues I mentioned on the previous slide is that individuals are trained in specific occupations. And so it's possible to define these objective match measures based on their training occupation, either discretely, so you could say, is that person working in the occupation they got trained in, or also continuously with measures of task similarity between the training occupation and the occupation that individuals end up working in. And then finally, and this is sort of an important point, speaking to or sort of telling us that these occupational matches matter. It turns out, and this is work that I've done myself in the same context, that we know that there's these large penalties if workers work in occupations that are different from their training. So there's big gains from matching, finding the right matches in this context. So occupational matches really matter for these workers. Or in other words, these occupational matches, they're really good indicators of match quality. And so to motivate this a little bit further, what I show in this graph here is two time series in the German labor market. The red dashed line is the unemployment rate in West Germany for 20 years from about 1990 to 2010. The dark blue line, solid line, this is the fraction of individuals in the year after they graduate from an apprenticeship working in the occupation that they got trained in. And so you can see is that the striking negative correlation, workers or graduates in years where the unemployment rate is lower have a much higher probability to start working in the occupation they got trained in relative to graduates that start when the unemployment rate is higher. And this is all conditional on full-time employment, so this is not driven by any mechanical effects. And the last thing I wanted to say here is that this is based on an occupational classification with just 13 categories. And so these moves are really sizable in terms of tasks. So they're economically meaningful. And the right-hand side is sort of change from 75 to 80%. That's intuitively a large change, given that these categories are pretty broad. And so before diving right in, let me give a little bit of an overview of what I do exactly and what I find, just in case I don't get to all these results by the end. So I start by setting up a conceptual framework, which is a very simple two-period selection model into occupations, where there can be two types of matching responses. One is an efficient response and the other one an inefficient response. And these two responses sort of mirror what I mentioned on the first slide about the two reasons why people may match less when they graduate into recessions. And then looking at the data, the causal effect of entry conditions, as or very similar to many other papers, I find that higher entry unemployment reduces earnings and does so persistently. So for at least 10 years, graduates face 2% lower earnings on average. Now, what's different from other contexts, and it's quite interesting, is that these earnings effects are actually driven by full-time wage effects. So I don't find any extensive margin effects on employment for these workers, but they simply just earn less on the jobs, but they don't struggle to find jobs. And then turning to match quality, I find that higher entry unemployment reduces job match quality for these graduates, as measured both by their probability of matching to the training occupation or task similarity. And this effect, again, is very persistent. So for at least 10 years, find these negative effects on matching. I don't find any effects of the unemployment rate in the year following graduation. So this is really an effect about entering the labor market. And then putting together these two results, and this is where I use my results from the previous paper on the causal effects of matching, find that this matching effect accounts for about 20% of the total effect on wages. And so this is to say that this is a channel that is economically meaningful for these graduates. It's not the only channel, which is consistent with other work that finds other reasons why graduating into recessions is bad for these cohorts. And then finally, I take the empirics to the conceptual framework, look at the mechanisms underlying match responses. And so here I use some newly compiled data on occupation-specific shocks to test the framework for predictions. And the takeaway here is that I find evidence both for efficient and inefficient matching responses following higher entry unemployment. But about 2/3 of these matching responses, they are inefficient. And I'll explain this, of course, in more detail when I get to the framework. All right, so let me be very brief on the literature in the interest of time. But I think this paper sort of contributes to 3 different strands of the literature. And the first one being fluctuations in job match quality. So there's this literature mostly using measures like tenure or overqualification or even job satisfaction that finds that we have these fluctuations in match quality over the business cycle. What I think I can contribute here is basically to show that there can be these persistent effects depending on what time of a worker's career you hit that worker. I can also explore the mechanisms underlying these effects in this context. The second literature then sort of more specifically looks or thinks about match quality as a match between a worker's skills and their occupations. And there's a bunch of papers that show that skills are not fully transferable across different occupations in the labor market. And what this given project, my new project, shows here is that this non-transferability of skills matters a lot for these labor market entrants, and can explain why they partly explain why they have these long-term earnings effects. And then finally, because it looks at entrants, of course, there's a large literature of number of papers looking at what happens if individuals graduate into recessions. This effect has been found in many different contexts, and there's sort of a subset of this literature that then looks at mechanisms, potential mechanisms. And one paper I should point out here is the Liu et al. Paper. They look at what they call skill match of graduates as well in the Norwegian college graduates context. I think what I sort of can add to this literature is that I can study match quality because of my context with an objective measure that's not based on wages. Because there is causal evidence on what matching does to wages, I can also quantify the effects and say like how much it contributes. And then this new data allows me to look at the potential mechanisms underlying match quality. Okay, so let me, to fix ideas, talk about this very simple conceptual framework that I have in mind. So this is a 2-period model that is very simple. Consider an individual who is trained in an occupation that I call K here, and then I think about sort of these 2 periods as the first one being the shorter run, the second one being the long run, and I look at what happens to people's wages working backwards, so starting in period 2. In period 2, log wages of this individual who's trained in occupation K, they're going to be given by this expression on the slides, which is the sum of a skill price per unit of human capital. That's this W bar term. Then there's a sigma term, and the sigma term is a match return that appears in this equation because the individual is trained in occupation K, and these are log wages in that same occupation K. And then there's another part, which is D, a skill depreciation parameter. And this one kicks in if in the previous period the individual did not match to their training occupation. So these are log wages in occupation K, and then in the outside option, K prime, log wages again depend on a skill price. There's now no match return sigma K because it's not the right occupation if you're trained in occupation K. There's also no skill depreciation because what D captures here is the full relative depreciation of skills, making the sigma term lower. So this is what happens to wages in period 2, and then using these expressions, if individuals select based on log wages, so they look for the highest return, they're going to work in occupation K if the difference in their error terms exceeds a threshold that depends on the match decision in the previous period. And if the difference in error terms follows a certain distribution, then we can write this simply as the probability of matching being given by 1 minus G of this threshold. And again, the threshold varies depending on whether you matched in the previous period, because that's going to affect whether your skills will have depreciated or not. Right. So with that in mind, this is period 2. Then moving to the first period, log wages here have sort of very similar structure. There's again a skill price per unit of human capital, which is this W bar. And then there's a sigma K again, which is a match return only in occupation K, because that's, again, this is an individual who's trained in occupation K, so they only get this benefit if they work in K. And then in both occupations, K and K prime, there's this expected term, the expectation of future wages, which depend on today's matching decision. And these expectations, they're going to include the probabilities from the previous slide, of course. And so again, if the individual now selects into an occupation based on their log wages, they're going to work in occupation K if the difference in their terms in that period exceeds a threshold. And that threshold has 3 different parts here. One is the difference in skill prices. So how well is one occupation doing relative to the other? It includes, of course, the skill match return, sigma K, and then this difference in expectations, expected log wages, which I've denoted by E of delta W2. Now, the first term here, this difference in skill prices, I denote this more shortly with W1 K prime K. And again, what this reflects is sort of how well is the occupation doing relative to another occupation. So you can think of this as demand conditions in that occupation. To make explicit that this depends on the general state of the economy, I denote or introduce a parameter which is Z1, which is simply the productivity parameter in that period in the economy. And I write that this W bar depends on this Z1. Now, if the derivative is negative, what that means is that if the productivity goes up, the occupation K prime, which is the outside option, is sort of sees less of an increase in skill price than my own occupation, then we'll have less matching from lower entry productivity. So in other words, like if the economy is doing badly, Z1 goes down. If this derivative is negative, it means that I see a relative improvement to the outside option. So I'm trained in a super cyclical occupation. The economy is in a downturn. My occupation is affected more than the outside option. And so I would match less because of this effect. And that's actually an efficient matching response. So if people decide to work in occupations that are different from their training because these other occupations are doing better, that's an efficient response, and we would see less matching, but it's an effect that actually mitigates the shock to some extent. Now, this is in contrast to another effect that I'm going to talk about now, which is that suppose there's a cost to matching to your first job that I call capital C, and that also depends on entry conditions. And I assume that this matching cost is counter-cyclical. So if the economy is doing better, Z1 goes up, then the cost goes up. The way to rationalize this is that in this context, and I'm going to say more about this in a second, individuals are trained in firms, and what happens is that if the economy is doing badly, a lot of them don't get retained by their training firm. And so if that happens, they then need to search for new jobs, and they also need to search for a job potentially in their training occupation. And so what this means is that it now becomes harder to find a job in your training occupation simply because you don't have this given offer of your training firm, which is obviously in your training occupation. And in terms of the equation, what it does is it sort of lowers the return to matching to your training occupation, or it increases the threshold that you need to cross to match to your training occupation. So this is red cost now added on the right-hand side. And so now if productivity goes down, Z1 falls, this cost goes up. that puts a wedge between your return and these two occupations, K and co-prime, you actually also match less, similarly to we saw on the slide before, but now this response is inefficient. So you match less, not because one area of the economy is doing better than the other, but simply because it's harder to find a job in your training occupation because you've been laid off, or you don't get an offer of retention of your training firm. And so both of these things lead to matching responses, but the implications are very different because yeah, this is not a response to a relative shock, and so it's an inefficient response. In terms of like, to summarize this in terms of the predictions, what this means, like, again, like extremely simple model, but just to conceptualize this, if there were entry conditions that one productivity falls, in total for each occupation, we don't actually know what happens to matching, because yes, you face perhaps more of a cost to matching to your training occupation, but you could sort of face relative shocks to the outside option. That means that you're still better off matching than working somewhere else. The second prediction is that because of skill depreciation, this D parameter matching responses will persist, whatever they are. If you react in the first period, you will also react in the second period. Thirdly, conditional on the relative shock. So let's suppose like the economy hits all occupations the same way. If we see a matching response, that's inefficient. And then finally, the relative shock itself should have an effect that's predicted by the model. And in particular, if the relative shock improves your outside option, then that should also lower your matching, but it does so in sort of an efficient way. So you match less for good reasons, because other areas of the economy are doing better. All right, so with this sort of in mind, let me move to say a bit more about the setting and the data before talking about the results. So as I mentioned, this is the German apprenticeship system that is sort of very similar in many German-speaking countries. In Germany, this is the main form of post-secondary education. So about 70% of individuals had gone through an apprenticeship in 2010. The way it works is that individuals are trained in firms for 3 days a week normally, and then they go to vocational school for the remaining 2 days. And apprenticeships, they typically last for 3 years. Now, it's important, I mentioned this before, apprentices, they're trained in specific occupations, which then allows us to observe what their training occupation is and define matches accordingly. So I used 3 different data sets that I'll sort of briefly talk about one by one. So the first one is the employment panel. I used 10 years of that from 1999 to 2010. This is a sample of Social Security records, which is based on about 80% of the workforce. So it doesn't include civil servants, the self-employed or military workers. The information that it has is daily information on or employment spells, and also demographics, some limited information on demographics. What's important is that both occupations and also the training occupations, they're recorded in what I call a field-based classification. And so what this means is that when individuals get promoted, they don't leave their category in the data. Which would obviously be problematic, because that's not the kind of changes we would like to pick up. People sort of, let's say, managing plumbers as opposed to being one of the plumbers. That's not what we would consider a field change. And then in terms of sample selection, what I do is I restrict the sample to workers who have one single training. They're continuously observed throughout that time period. I need to know their training occupation, location. I exclude people who move firms during their apprenticeship. And then finally, and this is an important restriction, I restrict the sample to graduates in the 2 months of June and July. And these are the most common graduation months. But the reason for doing this is essentially that because the unemployment rates are at the annual level and because the timing of these effects is so extremely important, I don't want to compare people graduating in January and December of the same year. So I just restrict this to the most common graduation months in June or July. This is a table of the summary statistics of that sample. So perhaps the most interesting information on here is really the second half of this table, where I list the different training occupations and their share in the sample. So I previously mentioned that I have these 13 categories that I use. The biggest ones are office workers, sales, financial workers, health and social, construction, and craft workers. They make up about 70% of the sample, and I guess from the names already, it's apparent that there's quite a wide variation of tasks that is covered by these in the apprenticeship system in general and by these occupations. So there's the more office-based occupations, but then there's also a bunch of more manual occupations included in these or trained in the apprenticeship system. Right, so then moving to the unemployment data. So the first part of this is really pretty standard. So I have state-specific unemployment rates that I can link to individuals' year and state of graduation. This is basically what it looks like. It's just a time series of unemployment rates across the different states that I can match to where people and when people graduated. And then the second part of the unemployment data, this is more special because it's new data, it's newly compiled data. And what this captures is unemployment by target occupation. The way this works is that individuals, they go to sign up when they're unemployed, they go to an employment agency, and what they're asked there is basically, what's your number one choice of occupation? What would you like to work as? And so what these rates capture is how many individuals are searching for a job in that occupation relative to everyone who's employed or searching in that same occupation. And so essentially what these rates do is they capture a risk of not finding work in your training occupation once they're linked to your training occupation. So if I'm trained in occupation A and this is the unemployment rate for occupation A, this is a measure of the risk for me to not finding work there because many people are searching relative to jobs in that occupation. Now, what I do with these...
Sorry, a quick question. So this target occupation is not necessarily the same as the training occupation?
Exactly, yeah, exactly. And this is actually really important because this is not necessarily a measure of the risk of not finding a job with your training, but it's a measure of not finding a job in your training occupation, if that makes sense.
So, but this is also a choice, or what is it?
It's a choice, yeah. So individuals, exactly. So they go and they're asked, where would you like to, what's your number one occupation? And so they record both, actually. So they record people's trainings occupation, and then they record what they would like to work in. And it's actually quite interesting in terms of like the documentation online. They make a big deal about how these two things are really quite different things at times. And so the reason why sort of this is a better rate for like a skill specific job for me in some sense is that if I had looked at the rate of unemployment for people with a specific training, that would be confounded by the possibility for these workers to find jobs elsewhere. Whereas this rate here is really like, you know, just how hard is it to find a job in that specific occupation? Not generally. You could find it easy to find work elsewhere.
And do these target occupations also vary with the business cycle conditions or no?
This is a very good question. So what I can show you in a second is that the rates, some are a lot more cyclical than others, but I think what you're asking is whether the reporting changes.
Right. Yeah.
Yeah, so that's something I don't have a good answer to be honest, because that's really hard to know, I guess, from
Mm-hmm.
because I have aggregate data on this. I know
Okay.
sort of what are the,
Mm-hmm.
but I don't know individually whether sort of people
Ah,
with the exact
okay.
same characteristics
Of course.
report different preferences.
Yeah,
But
sure, sure,
it's a
sure.
very good question.
Okay.
Perhaps anecdotally, I wonder if they would have some more
Mm-hmm.
information on this.
Yeah, thanks.
Yeah.
Thank you.
Right. So yeah, so I use these rates to create measures of sort of relative shocks for individuals. And the way I do this is I define sort of for each training J, what's the unemployment rate in your in that training occupation, and then I subtract from that the unemployment rate in the outside option. And the way I construct the outside option is it's like a weighted average of other unemployment rates where the weights are the fraction of people with that training working in these occupations. So if I'm trained in occupation A, then this measure of unemployment in my training occupation relative to the outside option would be the unemployment rate in that occupation A minus the unemployment rate in occupations that people with training in A typically work in. And so if that goes up, that means that the outside option is doing better. If the outside option is doing worse relative, then this measure would go down overall. And so this is what I promised over time, the aggregate rates and target occupation. So what you can see from this graph, I guess, is to some extent very intuitive. So construction workers, as one might expect, are the most cyclical visually in this graph. And there's a few others, like for instance, craft. There's also an increase in unemployment in the recessions of the early 2000s. But then there's other occupations, like for instance, health and social. There's barely any increase sort of detectable in this recession. And so what this, again, like this measure of your unemployment rate relative to the outside option captures both how bad is your occupation doing, but then also how are other occupations doing that you might be able to work in relative to that. And then finally, I use some data on tasks, and this is 4 waves of the German Qualification and Career Survey, which includes information on the occupations that individuals perform and the tasks that they report performing in these occupations. And I use these measures to construct an index of task similarity for each training occupation pair. And this measure or this index ranges from 0 to 1, where task similarity of 0 is basically 2 orthogonal task vectors, and then task similarity of 1 would be identical vectors. So it's the exact same occupation if it's equal to 1. So just to give a bit of a sense of the descriptors here. So what this lists is these task similarity measures that I just mentioned. So on average, it's about 0.77 here. And what I've listed here is the most similar and the most dissimilar training occupation pairs in the data. And so it sort of lines up with the intuition. Craft and electrical is very similar, whereas office and textile happens to be the most dissimilar, the most distinct two occupations in terms of the mix of tasks. And for the largest occupations, again, like the sort of numbers here are relatively intuitive, and that sales and financial and office workers, they have a high task similarity. They're both office-based jobs, but for instance, much lower task similarity for construction and office workers, which sort of, I guess, lines up with the intuition. Okay, so let me then move to the results. So the regressions that I run here, they're quite, well, they're similar to many regressions that people run when looking at entry conditions on different outcomes in the labor market. So what I have on the left-hand side here is an outcome for an individual I in cohort C, trained in state S at time T. And on the right-hand side, there's a bunch of different fixed effects for training, potential experience, cohort, state, and time. And then the variable of interest here is the one in bold, the unemployment rate for cohort C and state S. And I'm looking at the effect of this entry unemployment rate for different levels of potential experience, which is why the pi has the E subscript here. I control in these regressions for the current unemployment rate, URTS, with the gamma, but this is not necessary. So this is just to net out the current effects. I have results both controlling for these current unemployment rates or not. It's just that the interpretation of the pi parameter sort of changes depending on whether one includes this current unemployment rate in the regression or not. So in terms of labor market outcomes, this is the first table here of results. So what I show here is for a bunch of labor market outcomes in the different columns, the effect of the entry unemployment rate for cohort C and state S at different levels of potential experience. So this is what the numbers here on the left-hand side show, the 1 to 3, 4 to 5, etc. The first column is log earnings. So a 1 percentage point increase in entry unemployment rate reduces earnings initially by about 2.5%. And this sort of effect falls a little over the years, but it's extremely persistent. So it lasts for as long as I can observe people in the sample. And then in columns 2 and 3, what you can see is that this is not driven by any effect on full-time employment itself, not at the extensive margin, which is column 2. So that's any full-time dummy on the left-hand side. And then in column 3, yes, there's perhaps a little bit of a marginally significant effect on the days of full-time work, at least initially, but afterwards, that is no longer significant. So there's overall very little effect on employment here. And then conditional on full-time employment in columns 4 and 5. What stands out here is, first of all, in column 4, this is the effect of that I mentioned in the conceptual framework. People work less in their training firm. So even though they do work full-time, they don't work in their training firm. And then in the final column 5, you see that the earnings effect is really driven by persistent effects on full-time wages. Again, this lasts like up until I can observe people in the samples at least 10 years into the labor market. Now, I've looked at heterogeneity in these results across different trainings. The main takeaway here is that although the quantitative, like the numbers change a little bit, the big takeaway is that the big picture remains the same. So everyone has negative effects on earnings, no effect on full-time employment. Everyone's less likely to work in their training firm, and people have effects on full-time wages.
Excuse me, another question. And what fraction of each cohort work or are employed in the year after finishing the training?
I have a picture on this. There's actually been some change, should find it here, over time in this. There you go. So this is the full-time employment over time. So there has been a decrease in full-time employment over time in this cohort. It's like, I guess, more structural, but there isn't this sort of cyclical pattern which lines up with the results before. So on the right-hand side, I guess it's nowadays it's more around like 80%. It used to be closer to 95. Yeah.
Okay, yeah, I see. So they go on to university or whatever, right?
Yes, that could be sort of I guess one.
but it's not cyclical.
Yeah, or it could be, I mean, it could be part-time work if people sort of engage in that early on, but I guess that's quite a small fraction of yeah. But yeah, you're right. I mean, importantly, it's sort of it's not cyclical, but there is a fraction of people who just never really end up in full-time jobs afterwards. Yeah. So let me find my way back. Right, so this was like sort of the main labor market outcomes, and then turning to, well, before that, I sort of have a bunch of robustness checks, I guess, to show that this result is robust to a number of different specifications and checks. So one important thing, of course, is selective graduation. So I control for unemployment rates when people enter their apprenticeship to show that the results are not affected by that. I mentioned already that the year following graduation, unemployment rates don't have a significant effect on people's outcomes. I exclude movers as well, and then I exclude the observations in the years 2005-6. The reason for that is that Germany went through some major reforms in the labor market in that time, and so recording of unemployment rates by target occupation was quite poor in that time during those 2 years. Moving to job match quality, then same regression as before, just a different outcome here. Well, actually 2 outcomes. So one is a binary indicator whether people work in the occupation they got trained in. The second one is a measure of task similarity between their training occupation and their actual occupation they work in. And so main takeaway here is that there's these sizable negative and persistent effects on both of these measures. So the correlation graph from the very beginning essentially reflects causal relationships to a large extent. So it's not just a correlation that this initial graph showed. And again, these effects are sort of across the board true for all the training occupations. So these are I'm just showing the 5 largest ones, and of course there's heterogeneity in the sort of numbers here, but the qualitative picture is very similar. So everyone has this lower probability of matching, lower job match quality as a result of entry conditions. And so this exercise that then I do using these 2 results is essentially to ask, like, well, to what extent, I mean, do these 2 results just happen to exist in parallel, or can the match responses account for wage effects? So the typical recession in this time frame increases unemployment rates by 3 to 5 percentage points. Wages, this is the first set of results, fall by 4 to 6% for entrants, and also entrants are 5 to 9 percentage points less likely to work in their training occupation. And then I use the results from my previous paper on the causal effects of matching, where the average return was found to be 12%. To put all these numbers together and say that about 16 to 18% of the negative wage effects can actually be explained by worse match quality of these entrants. So again, there's other reasons why wages fall when people graduate into recessions, but the job match quality one seems to be a very like a sizable and economically meaningful effect. So it matters for these unlucky cohorts. Right, and so turning to the mechanisms, one thing that I mentioned already is that the total effect is negative, suggesting that matching costs and better outside options seem to dominate any potential worsening of outside options that people could see. So for everybody matches less with higher entry unemployment rates. Matches persist as well, which suggests skill depreciation. And then in order to distinguish between efficient and inefficient matches, now what I introduce in these regressions is this measure of the relative shock, this delta UR, which again is like the unemployment rate in your training occupation minus the unemployment rate in your outside option. So if this measure goes up, it means that your occupation, the one that you got trained in, is doing worse relative to other occupations. And so controlling for this effect, this table summarizes the results now for the first 10 years in the labor market combined, just to fit everything into one table. Again, for the two measures of match quality as an outcome, the first column shows in the first row that the unemployment rate at entry still has this negative effect on match quality, even after we condition on relative shocks to different occupations. And the magnitude of this effect, it's now about 2/3 of the original effect. And so this is to say that about 2/3 of the matching response with higher entry unemployment are not driven by any sort of relative shocks to different occupations. And this is the part which in the conceptual framework I termed the inefficient part. Now in the second row, like this measure of
sorry, can I ask another question? So to what extent is this result with this relative unemployment rate due to the construction sector? So if you left out construction.
I need to try this. I haven't actually run the regression without them. So I've run these regressions for the I've interacted this with different occupations, and so it seems to be true for the other occupations individually as well. But like to what extent sort of the average result disappears, I should run that regression. That's a good suggestion. Thank you.
Good.
Yeah, because that was the one that really sort of did pretty badly in comparison to the others. You're right. Yeah, absolutely. Yeah. Right. And so, yeah, in the second row here, then what I was mentioning was that the sort of improvements to the outside option itself, they also lead to less matches. So this is what the theory would predict. If your occupation has higher unemployment, sees more of an increase in unemployment relative to the outside option, then you also match less because now the outside option looks better. And so both of these sort of coefficients point to very different matching effects. The first one being sort of the inefficient one, but the second one reflecting efficient reallocation. And then finally, in the last two rows, interestingly I control for the current rates in both of these variables, the current unemployment rate and the current attractiveness of the outside option. And while the current unemployment rate actually doesn't affect matches significantly, if currently your outside option is better, people seem to react to these incentives as well. And so this is the negative coefficient in the final row here. Right. So just to summarize this before I wrap up. So again, like controlling for these relative shocks does weaken the matching effects. So some of the negative response to matches in response to entry conditions is because simply, other people find jobs in areas of the economy that are less affected, and so this is something that actually mitigates the shock. It's good, but 2/3 of this average response remains, and that's sort of, we can't explain by relative reallocation, and so it would be inefficient in this framework. And the better outside options themselves, they can be shown to have also negative effects on matching, and as I mentioned, this would be an efficient reallocation response. Okay, so let me wrap up, hopefully to leave some more time for questions. So what I find in this project is that adverse entry conditions persistently reduce the earnings of apprenticeship graduates, and these effects, unlike in other contexts, they're driven by full-time wage effects. I don't find extensive margin effects on employment. At the same time, this job match quality falls and falls persistently, driving about 20% of this wage effect. And so what this persistence means is that we see these long-term productivity effects from initial conditions. And then looking at the mechanisms, it seems to be that about 2/3 of this matching effect is not efficient, it's inefficient. not driven by relative improvements to outside options. There is also evidence for an efficient matching response, but it's smaller, and yeah, it's not nowhere near the full effect here. And then the final bullet point here hints a bit at policy implications, which is something that is like sort of currently something I'm working on to explore further, because like distinguishing between these different matching mechanisms has very important policy implications, because the story here is quite different. If people don't match less because they can't find the right jobs in the economy, that would speak to trying to address matching frictions in this framework, whereas if people reallocate efficiently to less affected areas, then we might want to think about if there's frictions that prevent people from retraining in these new occupations that they need to move to because of these relative shocks. Yeah, thank you so much for listening, and yeah, I look forward to more comments and questions. Thank you so much.